Today, we are going on an absolutely epic journey. It's a trip that happens billions of times a second, all around us, but it's completely invisible. We're going to go inside the internet itself to see how a single click can connect you to the other side of the planet in literally the blink of an eye. So picture this. You're browsing online, you find the perfect cat video, and you click play. And bam, a split second later, it's on your screen. But have you ever stopped to think about what just happened? What kind of magic occurred in that tiny fraction of a second? How did your computer find that one specific video on a server maybe thousands of miles away and get it all the way back to you? Well, to really get it, we're going to follow the hero of our story, a single, humble digital packet. I'm not kidding. This tiny little piece of data is about to take an incredible trip, and we're going to follow it every step of the way. Okay, so first things first, every journey needs a destination, right? Before our little packet can even think about leaving, your computer has to figure out the exact address of where it's supposed to go. And on the internet, that means it needs to do a special kind of translation. So what even is this data packet we're talking about? Well, your request to play that video is actually way too big to send all at once. So your device is smart. It breaks it down into these tiny little chunks. Each one of those chunks is a packet. And you can think of it just like a postcard. It's got a little piece of the message, and most importantly, it's got the destination address written right on it. Now, here's where that translation comes in. We humans, we like easy to remember names, like, catvideo.com. But computers, they don't speak that language. They talk in numbers. They need a unique numerical ID, what we call an IP address, to find anything on the network. So how in the world does your computer get the right number? Well, it uses something called the Domain Name System, or DNS for short. The best way to think about DNS is that it's the entire internet's address book. Its one and only job is to look up the human-friendly name you type in and find the correct machine-readable IP address that goes with it. And this whole thing, this DNS lookup, happens in a flash. Your computer basically shouts out, "Hey, where can I find catvideo.com?" A nearby DNS server hears it, looks it up in its massive directory, finds the matching IP address, and sends it right back. And just like that, address found. Our packet is officially ready to hit the road. All right, with that destination address stamped on its virtual envelope, our packet is about to start the very first leg of its journey, breaking out of your local network. And this first step is actually a really short one. The packet just zips across what's called your local area network, or LAN. You know it as your home or office Wi-Fi. It's just that little private network connecting your computer, your phone, all your personal stuff together. But to get from your little home network out onto the giant global internet, our packet has to go through a gatekeeper. And that gatekeeper is your router. It's literally the traffic cop of the digital world. It takes one look at our packet's destination address and directs it out of your neighborhood and onto the on-ramp for the massive digital superhighway. And now for the main event. Our packet has left the quiet residential streets of your home network and is now merging onto the busiest, most complicated highway system ever built by humankind, the internet itself. See, the internet is what's known as a wide area network, a WAN. It's this massive web connecting devices across huge distances, and our packet isn't going to travel in a straight line. Nope, it's going to hop from router to router to router, zipping through fiber optic cables buried deep under the ocean at almost the speed of light. And each little hop gets it closer and closer to that server with our cat video.
And every single one of those routers it meets does something called routing. It looks at the packet's final destination, and then, using some really complex algorithms, it decides what the most efficient next hop is. They're like these incredibly fast, super smart mail sorters, and they're always recalculating the best path to avoid digital traffic jams or slowdowns.
So you might be wondering, how do all these different devices made by all these different companies all speak the same language? Well, they do it through something called protocols. You can think of these as the official rules of the road for the internet. And the most important one is called TCP/IP. It's the set of rules that make sure all this data gets packaged, addressed, sent, and received the right way every single time. Let's break that down real quick. Think of it in layers. First, you have the content. That's your actual request for the video. Then TCP, one of our protocols, wraps it in a reliable digital envelope. Then IP, the other protocol, stamps the destination address on it. And finally, at the very bottom, it's all converted into physical signals, like little pulses of light shooting down a fiber optic cable, ready for the actual physical journey. So, after hopping across continents in just milliseconds, our packet has finally reached its destination. But hold on, the journey is only half over. Now the data we actually want, the video itself, has to make the exact same trip all the way back. Touchdown! Our little request packet arrives at the cat video server. The server reads the request, it goes, aha, I know what you want, finds the video file, and gets ready to send it back. The packet's mission? Total success. Now, just like your request, that video file is way, way too big to send in one piece. So the server does the exact same thing your device did. It slices that video up into thousands, sometimes tens of thousands of new data packets. Each and every one gets addressed to your IP address, and then they're all sent on their own return journey across the internet. So as this absolute flood of packets starts arriving at your device, that's when our friend TCP, the Transmission Control Protocol, really gets to work. It's basically the quality control manager. It checks that every single packet made it home safely. If any got lost along the way, it requests a resend. And most importantly, it puts them all back together in the exact right order. And what's the result of all that? The cat video plays perfectly, seamlessly on your screen. That whole thing, that entire round-trip journey, your one little request going out and thousands of video packets coming back, each one maybe even taking a different path to get there, it all happened in less than a second. I mean, it is just a mind-boggling feat of global coordination when you stop and think about it. So, now that we followed our packet on its wild adventure, let's just take a second to recap the real unsung heroes that make this modern miracle happen every single day. It all works because of these 4 key players. You've got DNS, the address book, which finds where to go. You have the IP address, which gives every device a unique digital street address. You've got routers, the traffic directors, guiding all the packets along the way. And you've got protocols, the universal rules of the road, that make sure everyone can talk to each other. If you take away even one of those pieces, the whole system just falls apart. And you know, it all comes back to this really simple definition. At the end of the day, what we just witnessed is the beautiful, complex reality behind that simple sentence. It's just connecting devices to share information. From your simple click to a global relay race of data, it all serves that one fundamental purpose. This unbelievably intricate dance of data, it happens flawlessly, billions of times every single second. It really makes you wonder, though, what happens when just one of those little steps goes wrong? When one router hiccups or one address lookup fails? Well, maybe that's a story for another time.